Hey everyone, hope you all are doing well. Welcome back on my channel, Plain Upskill. So this is going to be the third video on this channel, and starting from this video, we are going to focus on how to tackle the reasoning type questions, which is why I am going to create our first playlist on this channel named as the reasoning list. We are going to cover as much reasoning type questions as possible, and later on or simultaneously, we are going to create more playlists for various topics. So all you need to do is buckle up for upcoming videos, and if possible, maintain a separate book to practice these questions. And also, whether you are learning these questions from my channel or any other sources, it doesn't matter. What matters is you being serious to learn these concepts and never forget these, because these would come very handy and would prove to be very time efficient when the right time comes. So without any further ado, let's start with our trickeries. In this first episode of Reasoning List, we are going to start with one of the most popular problem type, that is counting figures. So let's start with the very basic ones and then gradually increase our level of difficulty. Count the number of triangles in the figures shown below. Let's see how well would you be able to answer these. Also, feel free to pause the video if you need more time. Ready? Here you go. Count the total number of triangles shown in the following figures. Done? I know most of you would have already answered the question and they wouldn't even have felt the need to pause the video, because these are the questions that we often encounter while practicing this type of question. So most of you would have already answered that figure 1 has 1 triangle, figure 2 has 3 triangles, figure 3 has 6 triangles, and figure 4 has 10 triangles inside it. Now let's see the methods you would have used to count the number of triangles. The most basic method to do so is by adding the total number of triangles formed on the base of the biggest triangle. In case of figure 2, there are 2 small triangles formed on the base of the biggest triangle. So here, the total number of triangles will be 1 plus 2 equal to 3. Similarly, in figure 3, there are 3 smaller triangles formed on the base of the biggest triangle. So here, the total number of triangles will be 1 plus 2 plus 3 equal to 6 triangles. Finally, in figure 4, there are 4 small triangles formed on the base of the biggest triangle. So in this case, the total number of triangles will be 1 plus 2 plus 3 plus 4 equal to 10 triangles. But this method might be convenient for adding until few number of small triangles, but would prove to be quite troublesome in case we needed to keep adding numbers till 8, 9 or 10 or higher. For example, in this case, there are 8 small triangles formed on the base of the biggest triangle. So if we kept adding numbers like 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, then there is a possibility of an incorrect addition and we might get our total number of triangles wrong. So in order to calculate the number of triangles more accurately, we use a formula to count the total number of triangles in such figures. And the formula seems like this: n into bracket n plus 1 whole divided by 2. This is also the formula for sum of natural numbers. As you can see, the method of 1 plus 2 plus 3 counting the smaller triangles on the base of the biggest triangle is similar to that of adding natural numbers. So this formula works here correctly. So if we use this formula in our current figure, where we can see 8 smaller triangles on the base of the biggest triangle, we can easily calculate the total number of triangles in this figure as 8 into 8 plus 1, which is 9, whole divided by 2, which gives us the total number of triangles to be 36. So remember, in this formula, the small n represents the total number of smaller triangles formed on the base of the biggest triangle. And when we substitute that value in this formula, we get the exact number of triangles formed in such figures. Now let's see some more examples of count the number of triangle problems. In these figures, How many number of triangles can you count? Give it a try by yourself. You have 5 seconds to answer. Done? Well, this was very easy one because this doesn't require any tricks to count the number of triangles. You can simply glance at the figures and count the number of triangles. Like in figure 1, there are 2 triangles clearly visible in it. In figure 2, there are 3 triangles. Figure 3 has 4 triangles and figure 4 has 5 triangles in it. But if you want to memorize this as a trick, then simply count the number of baselines of a triangle. Like in figure 1, there is one baseline of the biggest triangle and another baseline inside the triangle. So in this, we can clearly say that there are 2 triangles. In figure 2, there is one baseline of the biggest triangle plus 2 baselines inside that triangle. So here, there are 3 triangles in figure 2. Similarly, one baseline of the biggest triangle and 3 baselines inside the triangle. So here are 4 triangles in this figure. And lastly, in figure 4, there is one baseline of the biggest triangle plus 4 more baselines inside that triangle. So here, the total number of triangles inside this figure are 5 triangles. Well, this was the most easiest type of count the number of triangles problem. Now let's look at a little more complicated one. Now try to find out the total number of triangles in this figure. I'll also give you a hint. You can apply the previous 2 concepts that we just learned. Just give it a try. Done? I hope everyone would have tried to solve at least once. If not, then I would request you to give a genuine attempt because this is not that complicated one. And for those who have attempted this question, let's see how it's solved. First, let's use the formula method. So the formula goes like this: n into n plus 1 into m whole divided by 2. In this formula, n represents total number of parts the largest triangle is divided into by the vertical lines, and m represents total number of parts the largest triangle is divided into by the horizontal lines. Here we can clearly see that the largest triangle is divided into 2 parts by both horizontal and vertical lines. So in this case, n and m both are equal to 2. Thus, the total number of triangles in this figure using above formula is equal to 2 into 2 plus 1, which gives us 3, into 2 whole divided by 2, which gives us the total number of triangles equal to 6. This was the formula method. Now let's try to solve this using the hint I just gave. In the previous 2 concept examples, we learned how to calculate total number of triangles when the largest triangle is divided by vertical and horizontal lines separately. Now, let's try to merge both those concepts and then try to solve this example. If we use the baseline triangle concept, we can clearly see that there is only one horizontal line present inside the largest triangle. So we can say that there are 2 triangles. Let's refer them as 2 baseline triangles for simplicity. Also, in the first concept, we learned how to count the total number of triangles when the largest triangle is divided by the vertical line. In this figure, it is clear that there is only one vertical line, and we know that total number of triangles formed when there is only one vertical line is equal to 3, as we have learned previously. Again, it is noticeable that the vertical line bisects not one but 2 baseline triangles. That's why when we merge both the concepts, we get the total number of triangles in this figure as the total number of triangles in the largest triangle plus the total number of triangles in the smaller triangle, which is equal to 3 plus 3, which gives us 6 triangles. And thus, this is how we can solve without using formula and just utilizing our previous two concepts. And yes, using the previous two concepts would be useful when there are very few number of lines involved in the calculation, but if there are more lines bisecting the larger triangle, then the formula method is the most apt one to use. To get a firm grip on this type of question, let's try one more example. Find total number of triangles in this figure now. Pause the video to give it a try by yourself. So, did you give it a try? If yes, then let's see how it's solved. Right now, we are going to solve it using only the formula method. As we can clearly see from the diagram that there are 3 horizontal lines and 2 vertical lines, which means there are 4 base triangles in this figure, and the 2 vertical lines divides our triangles into 3 parts. So here the n value, which is equal to total number of parts that the vertical line divides our triangle into, is equal to 3, and m is equal to 4. So using a formula, n into n plus 1 into m whole divided by 2 gives us 3 into 4 whole divided by 2, which is equal to 24. And thus in this figure there are 24 triangles possible. And now with this much clarity, let's now quickly jump to the next type of problem. Now let's try to calculate total number of triangles in these 3 figures. Pause the video to give it a try by yourself, and when you are ready, keep watching the video. Okay, now let's see how it's done. In the first figure, you can clearly just count the number of triangles by observing the figure. You get the total number of triangles in first figure as 5 triangles. But when you try to do the same trick with the second and third figure, it might prove a little more complicated or a little more challenging. So the right way to do is by using a formula called 4n plus 1 formula, where n represents number of embedded triangles inside the largest triangle. But as we have already used n and m in our previous formulas, let's use k here to avoid any confusions. So in the first figure, there is only one embedded triangle inside the largest triangle. So which means here k's value is equal to 1, and thus total number of triangles will be 4 into 1 plus 1 equal to 5 triangles. Similarly, in figure 2, there are 2 embedded triangles inside the largest triangle. So here the value of k is equal to 2, and thus the total number of triangles in second figure are 4 into 2 plus 1, which gives us 9. And finally, in figure 3, there are 3 embedded triangles inside the largest triangle. Thus, the total number of triangles in figure 3 is equal to 4 into 3 plus 1, which gives us 13 triangles. So this is the way you can solve this type of count the triangles question. Now, let's jump to the second last type of problem of today's video. Let's try to calculate the total number of triangles in this seemingly difficult figure. So, in order to calculate the total number of triangles in this type of figure, we use this formula: p into p plus 2 into 2p plus 1 whole divided by 8, where p represents total number of triangles formed on the sides of the largest triangle. So in this figure, the total number of triangles formed on the side of the largest triangle is equal to 3. You can see that it doesn't matter which side you choose, because on all 3 sides of the triangle there are 3 triangles formed. So as we got the value of our p, which is equal to 3, when we substitute this value of p in our formula, we get 3 into 3 plus 2, which is 5, into 2 into 3, that gives us 6, plus 1 whole divided by 8, which is equal to 13.125. Now remember, consider only the integer part of the answer, that is 13 here, as triangle cannot be in fractional form. So the total number of triangles in this figure or in any figure is always a complete number. And in this figure, the total number of triangles possible are 13. Let's just look at one more example to get a better understanding of this sum. Let's try to calculate how many triangles are possible in this figure now. Well, when you look at it in the first glance, it looks quite difficult one, but after we know the formula, it's very simple now. As you can see, the number of triangles formed on the side of the biggest triangle in this case are 6. So here the value of p we get is equal to 6, and thus when we substitute the value of p in our formula, we get 6 into 6 plus 2, which is 8, bracket 2 into 6, that is 12, plus 1 whole divided by 8, which gives us the value 78. Thus, in this figure, the total number of triangles possible are 78. Also, in these type of sums, if you find this formula to be quite lengthy and time consuming, so there is this table which you can memorize and directly answer the questions based on the number of triangles present on the sides of the biggest triangle. Now finally, let's jump to the last type of question of today's video. Let's learn how to calculate number of triangles inside a square figure now. Would you like to give it a try? Pause the video. The ones who are continuing the video, let's learn how to solve this. As you can clearly see, there is a square with 2 diagonals, and now we need to calculate the total number of triangles inside this figure. If we just calculate manually, we can count that there are 8 triangles in this figure, which is correct. But the most apt way to do so is using this formula. But before going to the formula, let's conclude few things from this diagram. As you can clearly see, the 2 diagonals are dividing the square into 4 equal triangles. From this, we can make the formula as the number of parts the diagonals divide the square into multiplied by the total number of diagonals in square is equal to total number of triangles in the figure. Let's see if it works or not. As we can clearly see, there are 2 diagonals and both the diagonals divide the square into 4 parts. So the formula goes like number of parts into number of diagonals is equal to total number of triangles, which gives us 4 into 2 equals 8, which is the same as the number of triangles we calculated manually. Now let's go on to a little tougher problem. In this figure, there are 2 squares joined together in a row. Now, let's try to find out the total number of triangles in this figure. As from previous example, we know that total number of triangles inside one square with 2 diagonals on is equal to 8. So it's clear that there are at least 8 plus 8, 16 number of triangles. But if we observe carefully, there are 2 more additional triangles formed by the joining diagonals in blue and green color. So the total number of triangles formed in this figure are 8 plus 8 plus 2, which gives us 18 triangles. Let's see one final question of this type to gain full mastery over this type of problems. In this figure, there are 3 squares connected adjacent to each other in a row. Now we know that in one single square with 2 diagonals, there are 8 triangles in total. So in this figure, there are minimum 24 triangles possible in this figure. Now, as you can see the intersections where the squares are connected, there are 2 possible intersections formed. Just like the previous example, we know when there is one intersection between the adjacent joined squares, there are 2 additional triangles formed in it. And in this case, there are 2 intersections formed in this figure. So the number of additional triangles formed in this case will be 4. And thus the total number of triangles possible in this figure are 8 plus 8 plus 8 plus 4, which is equal to 28 possible triangles. And this is it, everybody. This was the episode 1 of the reasoning list, and here we conclude our today's video. Do tell me down in the comment section below what all new formulas did you learn in this video. Also, make sure to bring these questions in practice every now and then so you won't be forgetting them often. So this is it for today. We will continue in episode 2. Till then, stay tuned, subscribe to the channel, click the bell icon for notifications, and remember, keep learning, keep upskilling. See ya.